So example 2, again, we're going to think about the steps, getting a single logarithm, changing to exponential form, and then solving. And in A, there is a shortcut. So I'll show you first how you would do it if you had to solve it the way that we regular have, and then I'll show you where we can go and do the shortcut. And maybe you'll see the shortcut as well. So in A, I'm going to start combining things. I have adding, the bases are the same. So adding two logs with the same base is the same as multiplying. So I could multiply these together. And I get log 6 equals log 6, x plus 6 times x minus 1. And I'm going to draw a line here because it is at this point that there will be a shortcut. But I'll show you the shortcut after we go through the regular steps. So the regular steps say we need to combine to a single logarithm. Right now I have a log on both sides. So if I would want a single logarithm, maybe I'll multiply this out, x squared plus 6x minus, not plus 6x, plus 5x minus 6. In order to combine logs, first of all, they'd have to be on the same side of the equation. And then you're going to use your log laws. Is there a log law for subtracting? Yes. Subtracting two logs is the same as dividing. So I can divide by 6x, and now I have a single logarithm. You solve logarithms by changing to exponential form. So once you get a single logarithm, this is the step that you do next. This is log form. I change it to exponential form. The base is 10. The exponent is 0. And I think one of the reasons that this step is so hard to remember is because it totally changes what the equation looks like. You're used to, in equations, doing what you do to one side, you do the other side. You're used to your steps sort of looking like what was above with a small change. This step is a major change because you're using a definition to change from logarithmic form to exponential form. And for that reason, it makes it hard to remember. But now, what is 10 to the 0? 10 to the 0 is 1. If I multiply both sides by 6x, 6x times 1 would be 6x equals x squared plus 5x minus 6. And how do I solve a quadratic equation? I make one side equal to 0. Factor or the quadratic formula. This one factors nicely. Now you can't take log of 0 and you can't take log of a negative number. So we have to double check both of these answers if that ever happens. So I'm going to take 3. I'm going to go back to my original equation. Do you see if you plug 3 into the first one, 6 times 3 is positive 18. That's fine. Plug 3 into the second one. 3 plus 6 is 9. That's okay. Plug 3 into the third one. 3 minus 1 is 2. So when I plug in 3, I never run into 0. I never run into a negative number inside the logarithm. So I can put a little check mark, then 3 is fine. If I plug in negative 2, well, right away, 6 times negative 2 is negative 12. You cannot have a negative inside of a logarithm, so I can cross this one out right away. Now this one has a shortcut. And the shortcut, what's the problem with shortcuts? Is they only work in certain situations. They don't always work. Lots of the questions you have to do the regular method. So it's really good to know the regular method. But the shortcut looks like this. If I have log of 6x equals log of this, Does it make sense that the two green boxes have to be the same?
Yeah.
So the shortcut only works if you have log equals log. If someone had an extra +1 on one side, shortcut is impossible to use. It only works if you have a log on one side equal to a log on the other side. And if you have a log on one side equal to log on the other side, the inside, the green boxes, would have to be the same. And so I could right away just go and say, well, I know that 6x has to equal x squared plus 5x minus 6. And how much time did that save us? Well, that would take us all the way to there. Save us those 3 lines of work. Kind of nice. Plus, you avoid the step that you forget. Also nice. So the shortcut is helpful. So that's all I'll show you with the shortcut there, because that's all you need to know, because it's exactly the same after this. You would still solve, you would still get your answers, you would still check your answers, and cross out the one that's not possible. Okay, let's do B. I'll rewrite it here for you. 3 equals log base 2 x plus 2. Log base 2x plus 2 plus log base 2 of x. So again, I'm solving an exponential equation. I'm solving a logarithmic equation. I recognize it's a log equation because there's an x inside the logarithm. We solve log equations by changing to exponential form. That's that green step. But in order to change it to exponential form, you first have to have a single logarithm. So here, my rule for adding is multiply, and I'm just going to multiply right away. I'll get x squared plus 2x. I don't have a log on both sides, so I can't use the shortcut. Okay? So here's the green step. The base is 2, the exponent is 8, equals x squared plus 2x. I guess for those of you that really like shortcuts, technically, could you write 3 as log 2 of something? What would have to be here so that this side is equal to 3? 8. An 8. And then you could use the shortcut, although I'm not sure it's any faster in this situation. Do you see how that works? So anyways, we have a quadratic equation. I make one side equal to 0. I'll move that 8 over. Check if I can factor the quadratic formula. This one factors nicely. And we have to check. So if I plug -4 back into the original equation, be careful. Because if you plug -4 into this one, it appears to be fine. You always have to plug it back into the original equation. And when I plug in -4 in for x, -4 plus 2 is -2. I can't take the logarithm of 0 or a negative number, so this one I'd have to x out. Next, I check 2. 2 plus 2 is 4. That's okay. I check the second one. Log x of 2. That one is okay. So this answer works. You can circle questions 11 and 13. And I have a warning. The textbook just set you up to make a common error. Humans are really good at pattern recognition, but sometimes we recognize patterns that aren't true. So I want to point out something that your brain might have, like a subliminal message that your brain might have done to make sure you avoid it. We just did 3 examples. In the first example, we crossed out an answer, which was negative. In the second example, we crossed out an answer, which was negative. And in the third example, we crossed out an answer, which is negative. And all of a sudden, subliminally, your brain hears one message. My message I told you was you cannot take the logarithm of a negative number, which you have to check to see if it's negative. And then we crossed out 3 negative numbers. And so your brain sometimes makes a shortcut and say, oh, if the answer is negative, just cross it out. That is not true. I can make a question, in fact, I will give you ones later on, where the positive number doesn't work and the negative number does. So just because your final answer is negative, that does not allow you to cancel it out. You have to plug it back into the original equation. And if the original equation equals 0 inside of a logarithm, or a negative inside of a logarithm, then you cancel out. I can give you an example where you get 2 positive answers and both don't work. And I can give you an answer where you get 2 negative answers and both of them work. So just because the answer is negative, that doesn't mean you cancel it. So I'm a little bit mad at the textbook for doing this, because they definitely set people up to sort of like, oh, maybe I should do that. And that is not true.